In this particular question, we are given a polynomial equation, so this one here, okay, and we're asked to determine the velocity when the position is 0 for t is t is greater than or equal to 0. So determine the velocity when the position is 0. Okay, so just to recap on how this all works, we've got our displacement, which is given by x, okay? And so that is x of t. We have our velocity, okay? And by the way, this is in kilometers. Our velocity, which is equal to the differential, the rate of change of our displacement. And that is in kilometers per minute. So per minute there. Then we have acceleration, and that is equal to the double differential of our displacement, and that is in kilometers per minute squared. So now that we've got that, let's just plot this thing to get an understanding of what's happening here. So let's plot it. I'll clear my previous work. So that's 3 times by x to the power of 4 minus 12 times by x to the power of 2. Okay, I'm going to plot this one and I'm going to zoom in. Okay, so we can see that there's like a little bit going on here where it goes into the negative and then back up there. So for this one, determine the velocity when the position is 0. So given that x is equal to 0, what's our value of time? All right, now we've got a couple of examples here. So if we click on here so that we bring up analysis, whereas if you're in this one, you don't get it. So click onto this one, analysis, G-solve, we're going to find our roots. Okay, so we've got a root at x is equal to -2. All right, well, that is outside of t is equal greater than 0, so we're going to ignore that. We've got one that occurs when t is equal to 0. We're also going to ignore that because it's got to be greater than or equal to, which is a bit tricky. And then finally, this is the one we're interested in. Okay, so let's go through our process again. We've got, in this case, x of t, that is equal to 3t to the 4 minus 12t squared. All right, solve. We want to solve for t when x equals 0. Another way to write this, more mathy, is just say, and then you can say solve for t. Okay, so let's go into main because it's a little bit easier, and let's write out this equation once more. Okay, let's say that's equal to 0, and I'll highlight the whole thing, interactive, advanced, solve, and I'm given a lot of possibilities. So t, I know it's confusing. I put x in there. I put x in there because it's easier. But you should, that's why I recommend doing it, because you've got access to the x variable so quickly. So I just recommend putting it in and then converting it, but just remember to convert it. So t is equal to 2, 0, and 2, and we want to ignore -2 and 0 as t must be greater than 0. Okay, and the original question was asking determine the velocity, all right, when the position is 0. So what we want to do is find the velocity at point this, okay? And we can just say, that's what we want, right? So we're just going to say use calc. All right. Now, it's 3 marks. I think 1 mark for getting all the answers of t, 1 mark for saying which is to ignore, which variables are t to ignore, and then the last is the answer. So we can jump straight to the answer by grabbing all of this, bringing it down, And we're going to go interactive calculation diff. And we want to differentiate it at a value, and the value that we want to differentiate it at is 2. And so this is equal to 48. Okay, and if you really want to get fancy, you can write the, the formula that you used in there. Otherwise, the next step that you could do is just say diff and then differentiate it and say that v of t is equal to 12t to the 3 minus 24t, and then substitute it in. But I think it's just easier to say use calc. And that should be all the marks. There's 3 marks to that question. The next question is asking us to determine the velocity. Is given, so the velocity of the robot is given by this. So it's a new velocity. And if the initial position is 2 kilometers, find the position and acceleration. Okay, so we're given the velocity, the v of t is equal to minus 5 plus 3t. Okay, so we can say that a of t is equal to the differential of v of t. Now, determine that the velocity of a robot, or the velocity of the robot is given by this, and it's a new velocity. So that's what's missing here, is just to say the new velocity. Okay, so let's grab our calculator out again, and we're just going to wipe everything because we're starting a new question, part B here. So it's minus 5. I'll go 3x minus 5, so it doesn't bring up answer. By the way, if you want to stop it doing that, because it's a bit annoying, right, that it brings up answer, you can either delete it yourself, or on your calculator, you've got this like minus sign in the brackets, and that one doesn't bring it up. So minus 5 plus 3x, and we're wanting to differentiate this. So interactive calculation diff, all right, and that is equal to 3. Okay, and we're just going to say use calc, or used calc. And then a at this value is always still equal to 3, which is great. Now the problem is that our displacement, all right, when we differentiate that, that's equal to our velocity. But now we want to differentiate that. So another way of writing that same equation here is by saying d dt of x t is equal to velocity there. But now let me take the integral of both sides. These guys essentially cancel out, and we're left with xt is equal to the integral of velocity. Oh, I've accidentally put dx. That's meant to be a dt. Promise. Okay, so now when we do this, we can use our calculator to say that it will be that minus 5 plus 3t dt. But this will give us, unfortunately, an integration constant. So if you've never come across this before, what is an integration constant? Let's take a really simple example. I have a graph here, and this is y is equal to 2x plus 1. All right, so it's something like this. Now, if I differentiate this, y dash would just be equal to 2. Okay, so I'm going to plot this guy in a different color. Now, let's say I didn't have this one at the top, and I'm wanting to integrate the bottom one. Okay, all I know about my equation is that my gradient, my m, is equal to 2. Okay, however, right, when I know that my line is always given by mx plus c, but I don't know my plus c. So given that I know the gradient is 2, I have an infinite number of possibilities. I could have an equation like this, an equation like that. I don't know my plus c. It could be y is equal to 2x minus 3. I don't know. And this is what happens. We're given our gradient, but we're not given our value of plus c. So we need to be given a point, say somewhere here, and say we know that that's point -1 and 0, or I'm not sure exactly on the top of my head, but there's some point there, and we can use that to find the value of point C. So now that we know that, all right, we're going to grab this guy, pull him down, and we're going to go interactive. Oh, the easiest way actually, you can highlight the whole thing here, go to Math 2, and we can just write this one here. So we just need like an integral per se. So you can either do it like that, which is an integral, or you can go around here, interactive calculation integral, okay, indefinite integral, and that gives us the same thing. But in this case, it doesn't give us our plus c, so we just need to remember that. Okay, we need to remember that we've got our plus c. So let me go back to white. X of t is equal to, and we can say 1.5. I'm just going to put it in standard to make my life a little bit easier. So I've got 3 on 2 t squared minus 5t plus c. Okay, but now I'm given a point here. I am given the point, okay, so the initial position is 2 kilometers. All right, so this is equal to 2. Okay, so solve for c using calc, and we can say c is equal to, and so we're going to grab all this one, put it here, say plus x, like this guy. Now there's like a few places in here you can like manually input 0 for each of those, but I like to use a different thing. I like to keep it as x and say, in this case, it's equal to 2, and use this given that symbol. So that's a math 3, given that x is equal to 0. Okay, there we go. So it says c is equal to 2. All right, and I guess that makes sense because all of those values there, like this whole value here is going to be equal to 0, this whole value here is going to be equal to 0, and so we've got c is equal to 2. But otherwise, you might have to go interactive, advanced, solve for value c, and then it will give you the value c is equal to 2. Therefore, our final equation is 3 divided by 2t squared minus 5t plus 2. And there you go. There's lots of exam questions like this on my website. You can find it in the link below. And these are exam level questions, so you're not getting stuck with questions that aren't going to be appearing in your exams and tests, and therefore wasting time. So check out the website. If you like this video, share it with your friends. Otherwise, give it a like. And if you need any extra help, reach out to me. I offer tutoring services and would love to help regardless.